So is basically to help you set up your own trigonometry basics card. I have this great big index card that I like to use the front and back of. So you can put this on a piece of paper if you'd like, or you can use the front and back of cards. I have some in my classroom. So at the top, I put trigonometry basics card, and the first thing I put on there is the table of values. And if you'll notice, I go up through quadrant 1 right here, and then I have the quadrantal angles there as well with 0, 90, 180, and 270. I don't put 360 because it's the same as 0, so it'll match the top line. Now, if you look at this, next to those in degrees, I have in red the radians. So because pi is considered 180 degrees when you convert, if I take pi and divide it by 6, that's going to be 30. Pi over 4 is 45. Pi over 3 is 60. Pi over 2 is 90. Pi is 180. And 270 is 3 pi over 2. Then I'm going to come over here to the right. And if you look at this unit circle for quadrantal angles, as you look at this unit circle, I count and take care of the 4 quadrants. And so I set this up. I actually use the tool so it's nice and round. And I put the 4 points on our unit circle as the point 1, 0, with 0 at pi over 2, it's 0, 1. At pi, it's negative 1, 0. And at 3 pi over 2, it's 0, negative 1. Now recall that all points are sine of the angle, cosine of the angle, x and y. So if I come over here where I've started here, you can see where I can put in the point. It's just backwards because the way the table is, it does your y values first before your cosine. So in green, you'll see I put the 0.10 there, but it's backwards for 0. 90, okay, is 0, 1, but it's backwards. 180 is negative 1, 0, backwards. And 270 is 0, negative 1, and it's backwards, okay? So those are your quadrantal angles. Now, to do a tangent is y over x or sine over cosine. So you can go through with those green ones, divide through, you'll get 0 and 2 zeros at 0 and 180, and then undefined at 90 and 270. So that's what's in blue. Now, if you look at the rest of this as we fill it in, you'll see I picked different colors, but you'll notice the colors will match up. So I have the sine of 30 degrees, or the sine of pi over 6 is 1/2, which is the same as the cosine of 60, and those are both in blue. The purple is the sine of 45 and the cosine of 45 are both radical 2 over 2. And the sine of 60 is equal to the cosine of 30, and those are in that pink. So there's a pattern. It's if you come down for sine, because sine starts at midline, cosine starts high. Sine starts at 0, goes up to 1, so it's 1/2. Radical 2 over 2 and radical 3 over 2 up to 1. Cosine, it goes backwards because you start high from 1 and go down to 0. Radical 3 over 2, radical 2 over 2, 1/2, and then 0. Then the only thing remaining is to fill in the tangent. So when you divide it through sine over cosine, you're going to get radical 3 over 3 for 30 degrees and radical 3 for 60. So you can go through that. I expect you to know. I would make cards out of it. I'd move them around, flip around, make sure you understand it. So there is kind of a basics of the main angles for quadrant 1 and all your quadrantal angles. Now, you flip your card over on the back, I have this. So I have the quadrants over here. So I have the points of positive, positive, negative, 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 and positive, negative. And we also go through and label our quadrants like this. This is quadrant 1. Quadrant 2, we use Roman numerals. Quadrant 3 and quadrant 4, we go counterclockwise. You'll also see the letters, all A, S, T, C, all students take calculus. That helps you tell you what the values or the sign, not the values, but the signs of your trig functions in those quadrants. Personally, I look at the points and notice that all my points are cosine sine, so that helps me. In tangent, I always tell everybody, I want you to think of tangent of an angle is the same as saying your y's over your x's. So I want you to think of it as slope. So if you were to look at what tangent's doing, tangent's positive in quadrants 1 and 3, because if I were to draw a line there, that would be positive slope. If I draw it between 2 and 4, it'd be a negative slope, therefore tangent's negative. And by knowing what our three main functions are doing, you can actually figure out what the rest are doing, as in cosecant, secant, cotangent, because over here I have them called the cousins. I call sine and cosine my building blocks. You can write every other trig function in terms of sine and cosine. And then once you know what sine, cosine, and tangent are doing, cosecant does exactly what sine is. So I always call them the cousins, even though they're reciprocal functions, because all of us have that annoying cousin that follows you around everywhere you have a gathering. So if you know what sine's doing, cosine's doing it. Cosecant, excuse me. If you know what cosine's doing, secant's following along cosine. If you know what tangent's doing, you know cotangent's doing the exact same thing. So the signs will match for that. You just have to flip their values because they're reciprocals of each other. So that's what's in the green. And again, you can write all other functions in terms of sine and cosine. And the last thing I put on my Trig Basics card is the Pythagorean Identities. And the main one is right here. Sine squared plus cosine squared equals 1. Sine squared of an angle plus cosine squared of an angle equals 1. If I go through and divide that exact function by sine squared, I get my second identity here. If I divide the original starred one by cosine squared, I get my third identity. So in all honesty, guys, I don't know these as well because I can derive them, but this is very important that you know that the Pythagorean identity, if you have sine squared of an angle plus cosine squared of an angle, you get a 1. So there's a little bit of how I would do this for trigonometry basics. I will put this up, so this will be in the classroom. It will also for you to make your own card, and then you'll have this as we go through the course.